Okay, so for number 4, we're interested in suppose I move my chair 3 feet closer in the classroom. So I'm a student in this class, and noticing that I have this correlation, it's a negative correlation, meaning sitting closer tends to lead to higher grades. I try to use that to my advantage, and I move my chair 3 feet closer to the board. So with 93% confidence, what should I expect will be the effect on my next exam grade? Okay, now the hint here is we're talking about with 93% confidence. So this is referring to some sort of confidence interval estimate. So maybe when we talk about the effect, we won't be saying a particular number, but an interval of numbers. So think about that. Pop over to your grades regression worksheet and think about how we might answer this question. All right, so let's talk about the solution here. I'm going to give myself just a little bit more space. Right? So keep in mind, remember the slope of our regression line times change in x roughly predicts the change that I should expect to see in y. Now, the only hitch or new part with this problem is that I'm talking about a 93% confidence. So I'm actually referring to the confidence interval for the slope term. And I want to take that confidence interval for the slope term and change it into a confidence interval for the change that I would expect to see in my next exam grade. So first of all, let's pull the confidence interval for the slope term. Remember, the easiest way to grab information from our other workbook is to just use a cell reference. So I'm going to jump into the grades regression after hitting equals. I'm going to pull the lower 93% estimate for my slope term. So this is the negative 2.374. I'm also going to pull my upper 93% estimate. Okay? So these here, this is the confidence interval for the slope term. And I want to use this idea here. The slope times the change that I'm expecting in x should give me an expectation for what the change in y will be. So in other words, if I take these numbers and I multiply them by the change I'm expecting to see in x, in other words, I'm going to move my chair 3 feet closer. Oops, let me make that a different color. I'm going to move my chair 3 feet closer. All right, if I multiply by what that change in x ends up looking like, I'll be able to estimate what my range of exam grade effects are going to be. So first of all, keep in mind your change in x. If you're moving 3 feet closer, the distance to your board is actually decreasing. So we're going to think of this as a negative 3. Does that make sense? If you're decreasing your distance to the board, which is what you would do by moving your chair closer, you're going to think of that change as being a negative. Right? Now what I'm going to do is do a confidence interval for my expected change in y. Give myself a little more space. So Ci for change in y. And all I have to do here is take this value and multiply by the change in x that I'm trying to estimate here. All right, so I'll take the lower term, multiply by the negative 3, and I'll take my upper term and multiply by negative 3. So this tells me that if I move my chair 3 feet closer, I should be able to expect anywhere between a 7-point increase and a 5.5-point increase in my grades. So keep in mind, these are increases in my exam grades. Okay, so this is what we've finally arrived at. And this is more at the population level because I'm using a 93% confidence. So I'm using a confidence level. So here's my final answer here. Based on the confidence interval for the slope term, I would expect that moving my chair 3 feet closer, which is a change in x of negative 3, would lead to between 5.59 points and 7.12 points of an increase on my exam for next time. Okay, so this is my final answer. I'm just going to box it off to make that clear. So based on the confidence interval, that's here for my slope term, incorporating the fact that I know I have a change in x of -3, if I use my formula and I scale that, I get a nice prediction, a 93% confidence interval prediction for how much I should expect my grade on the next exam to change, anywhere between 5.5 points-ish and about 7 points. Okay, last two problems. Here's number 5. There are 3 chairs left in the room, and the distances to the board are recorded below. Predict the exam grades for the students that sit in those seats. So here we're using our linear regression to make predictions. See if you can remember what command or what approach you can use to actually make these predictions. Pause the video and give it a shot. All right, so if you started using the trend command, you're on the right path. If you had trouble using it, remember this is an array-based command, so you have to highlight first, then type out your command, trend. It asks for the known y's, so this is coming from our data, B3 to B68. It asks for the known x's, this is A3 to A68. And then it asks for our new x's, and that's the distances to the board that we're trying to use to make our prediction. Remember, the constant argument's always set to 1. We're going to hold Control, Shift, Enter to finish our make our predictions. So hold down Control, hold down Shift, and now hit Enter. And these are going to be the predicted exam grades based on these distances that those students sit to the board. All right, last but not least, we already kind of covered this, but we're asking the question, can we trust the results of this regression analysis? In other words, how do we know that the inference and the estimates and all the stuff that we've been interpreting above actually are trustable, right? Do they satisfy the assumptions that a linear regression requires? So try to remember where we look in order to determine whether we can trust our regression analysis, and write a sentence or two explaining whether we can trust them and why. All right, so remember, we have 2 plots which help us determine whether or not we can trust our regression. One is the residual plot, and one is the normal probability plot. They test different things. The residual plot should look like some random scatter with about half the points above and below with no discernible pattern. The normal probability plot should have the dots more or less following a line. So in both cases, these look like good diagnostic plots. So we're just going to wrap this up. We'll say, yes, the assumptions of the regression seem satisfied based on the fact that the residual plot has no discernible pattern and looks like random scatter, and the normal probability plot follows roughly a straight line as we would like. Okay, so just giving ourselves a quick look at those 2 diagnostic plots. They look the way they're supposed to look. And again, I've been a little vague about these assumptions. I don't want to get into too much detail, but just quick checks. This should look like random scatter, and this should more or less follow a nice line. So you shouldn't see any big drastic curves up, down, or S shapes or anything like that. This should look more or less like a line, linear. All right, so that was a lot. That was our second example. Take a little break and we'll jump into the last example.